Hi, I'm Allison, and for the challenge for today, we have to solve for T for M to hit the ground.
Hi, I'm Bailey, and I'm going to explain the diagram. So we have an inclined plane with a two-mass pulley system, and we're assuming that the pulley is massless and frictionless.
Hi, my name is Kevin, and we're going to derive this second kinematic equation in terms of finding height for this two-mass pulley system. We're going to assume that the initial velocity will be 0 meters per second and that the displacement will be 0 meters, so we can refer to height as delta x in our kinematics equation. Now h will equal 0 plus 0, and we'll have plus 1/2 acceleration missing time squared. Therefore, 1/2 acceleration time squared.
So now that we have the equation derived for height, and we need to solve for time, we're going to write this in terms of t. First is the equation, and then we're going to multiply it by 2. The 2 and the 1/2 of h equals a t squared. And then since we want to divide by a, so we have to get rid of the square and root 2h over a.
So now we have a derived an equation for acceleration because it is not given. In order to do that is deriving an equation with the things that we are given. We're going to use F net that equals the sum of all the forces to derive an equation for A. So now we redraw the diagram because some of the forces cancel out, and these are the forces that we left with. This is going to be negative and this will be positive direction. Now we have to add the friction force, the gravity force of X, and the gravity force on N in order to get
Since
the
we know
F net.
that F net equals the sum of masses times acceleration, we can substitute F net for that in our equation, and this is what our equation will be equal to.
Now we have to solve for Fg of M. We know that is equals M times G, and it will be positive in our case. Now we broke up the components for Fg to get Fg of X that equals M times G sine of theta, that it will be negative. This is positive because previously we decided that this direction is going to be the positive direction and this will be the negative direction. The last thing that we have to do is find the kinetic friction, and in order to do that we know that it is equals to the coefficient of kinetic times the normal force. In this case we don't have the normal force, but when we break up the components for the force of G, or force of gravity, we know that Fg of y equals M times G cosine of theta. So now we can substitute this one for the normal force because it's equal but opposite, so we get the kinetic friction. So now that we have everything here in this equation, our last step we can do is divide everything for the sum of all the masses. So this will cancel out and we get with A equals Now that we find A, we can plug it into our original formula in order to solve for T. This will be our equation, so our very last step that we're going to do is do some algebra in order to simplify and make this equation a little more pretty. So this is how we get the equation for time.